Is
Talk about the chemical properties of nitrogen dioxide gas. One, it supports burning. That is, burning metals when they're exposed to the gas, they do burn. So the burning continues. This is because when burning metals are exposed to the gas, we shall see that the gas decomposes to form actually oxygen, which supports burning. That is, for instance, when you have burning magnesium, burning phosphorus, burning copper, and so on, they do produce actually the corresponding oxides of the metal due to the formation of the oxygen that is from the decomposition of the nitrogen. Then secondly, we shall see that the gas itself has some oxidizing ability. For instance, when the gas is exposed to, say, the hot copper metal, the copper metal will actually be oxidized to the black copper oxide, that is turning from brown, and then we shall that it will have a coating of a black material on top of it. That is after it being exposed to nitrogen dioxide, and it itself it will be reduced to nitrogen. So that's another property of the brown gas or the brown fumes of nitrogen dioxide gas. Still, we shall see that this gas has also another property, that is at higher temperatures, which are like above 150 degrees Celsius, the gas normally decomposes, that is, to oxygen and nitrogen monoxide. So I think we can say that the color fades out. The brown color of the gas normally fades out at higher temperatures, that is temperatures above 150 degrees Celsius. You find that this gas or the brown color will disappear due to the formation of the nitrogen monoxide, which is colorless, and oxygen gas, which is also colorless. That's also a property of the nitrogen dioxide gas. Still, we shall see that this gas is slightly soluble in water, or sparingly soluble in water, that is forming an acidic solution. This solution will contain nitric acid and nitrous acid. So it contains a combination of nitric acid and nitrous acid. So due to the formation of these two, so that's why normally this gas is referred to as a mixed acid anhydride, because due dissolving in water, it forms what we call a mixture of more than one acid. So two of them, that is nitric acid and nitrous acid. Then the solution being formed in this case, it will be a pale blue solution being produced. But then that color normally fades out after time, because the formed nitrous acid further reacts with the atmospheric oxygen to form a nitric acid. So meaning that this nitrous acid is not there temporarily. Actually, it's not there permanently. Sorry for that. It's there temporarily. So after it's being formed, it will further react with the atmospheric oxygen in case the solution is being exposed to air. That is an assumption. So if it's not exposed to air, of course you will remain with both of the acids mixed together, that is nitric acid and nitrous acid. But if at all the components or the mixture is exposed to atmosphere, the atmospheric oxygen will react with form nitrous acid to form a nitric acid. So mean that the whole solution now will turn to be nitric acid. So that's also a good property of nitrogen dioxide dissolving in water, forming a mixture of those two acids. Then still, we shall see that this gas actually, when reacted with alkalis or an alkaline solution, for instance sodium hydroxide, potassium hydroxide, and a number of them, calcium and so on, actually it neutralizes what we call the alkalinic ability, or the basic ability of this solution, or the alkaline. So in other words, we can say, or in simple words, we can say that it neutralizes the alkaline solutions. So meaning that if at all you have your gas, then you dissolve it in any of the alkaline. I'll give an example of, say, potassium. You form the corresponding nitrate and nitrite of the metal together with water. So in the due course, the alkalinic ability, or the basic ability of the alkaline, will be neutralized. So that's also a good actually a good use for it in case like one needs to neutralize an alkaline and you have one but then you want to go rid of it. So in the due case of that, we shall say that if at all you have a nitrogen dioxide in place, then you can dissolve the gas in a aqueous solution of the alkaline, and it will be neutralized there and then. So as simple as that. So that's how actually you can utilize the alkaline. So that's also a good property of nitrogen dioxide. Then I don't know, I can't think about more, but then there are many of them, but those are the ones I can think about right now. That is, we have talked about it supporting burning, okay, of metals. Then it being actually an oxidizing agent, though for it to be reduced in the due course of being oxidizing, it loses its color. The brown color fades out. And then at higher temperatures, we have seen that this gas actually also loses color, or it decomposes to oxygen and nitrogen monoxide. Then the gas itself is slightly soluble in water. Okay, so slightly soluble in water, that is forming a mixture of acid, nitric acid, and nitrous acid. Okay, then I think lastly I've ended by saying that this gas actually, when dissolved in alkaline, neutralizes the basic ability of the alkaline, or it neutralizes the alkaline itself. And in due case, you form the nitrate and the nitrite together with water. So meaning that it's still, if at all like you want, it can be used to form, or in the preparation of the nitrates, of those corresponding metals that form the alkaline solutions. Okay, so those are the ones I can think about right now, but then still I know we have more of them, so we can think about more. So guys, actually those actually with questions, you can comment down there. Then still you can comment if at all like there's something I've messed up with, but in simple terms, that's what I can give for the case of the chemical properties of the nitrogen dioxide gas. So